हेलो स्टूडेंट्स, आप सभी का हमारे चैनल विद्या क्लास 10th में स्वागत है। स्टूडेंट्स, इस क्लास में हम देखेंगे क्लास 10th केमिस्ट्री का चैप्टर मेटल्स एंड नॉन मेटल्स। स्टूडेंट्स, ये इस चैप्टर का सेकंड पार्ट है। इसका फर्स्ट पार्ट हम पहले से ही अपने चैनल पर अपलोड कर चुके हैं, तो अगर आपने वो वीडियो नहीं देखा तो आप पहले जाकर उस वीडियो को देख सकते हैं। उसे मैं आई बटन में भी ऐड कर दूँगा और हमारे आप चैनल पर भी जाकर पे उस वीडियो को देख सकते हैं। स्टूडेंट्स, ये नोट्स बहुत ही ज़्यादा इफेक्टिव है और इन नोट्स के साथ में मैं आपको एनसीईआरटी क्वेश्चन आंसर्स भी दूंगा इस चैप्टर के, तो इस वीडियो को एंड तक ज़रूर देखें। स्टूडेंट्स, हर पेज को रीड करने के बाद मैं उसे लैंडस्केप में करूँगा, जिससे आप इन नोट्स का स्क्रीनशॉट भी ले सकते हो और बाद में रिवीजन के लिए आप उनका प्रिंट आउट भी निकलवा सकोगे इन नोट्स का। चलिए स्टूडेंट्स, इस वीडियो को स्टार्ट करते हैं। सो हमारा नेक्स्ट टॉपिक है जो कंटिन्यू करेंगे हम, वो है कोवलेंट बॉन्ड। कोवलेंट बॉन्ड, द केमिकल बॉन्ड फॉर्म्ड बाय शेयरिंग ऑफ इलेक्ट्रॉन्स बिटवीन टू एटम्स इज नोन एज कोवलेंट बॉन्ड। इट इज़ ऑफ थ्री टाइप्स: सिंगल कोवलेंट बॉन्ड, डबल कोवलेंट बॉन्ड एंड थर्ड ट्रिपल कोवलेंट बॉन्ड। Single covalent bond. Covalent bond formed by sharing of one pair of electron between two atoms. You can see the example, students. Take the screenshot. Next we have double covalent bond. So covalent bond formed by sharing of two pairs of electrons is known as double covalent bond. See the example, students. All the this type of diagrams are also there. Next is triple covalent bond. Covalent bond formed by sharing of three pairs of electrons between them is called triple covalent bond. Example is also there. Next is we have a question. So the covalent bond for Cl2, CH4 and CO2 and NH3. So Cl2 and CH4 are in single bond and CO2 NH3 will see. Take the screenshot. You can see on this page, students, all the answers are also given of the covalent bonds. Please take the screenshot. Next, we will read about the properties of ionic compound. So the properties of ionic compounds are: first, they are usually crystalline solids. Second, they have high melting and boiling point. Third, they are usually soluble in water but insoluble in organic solvents like ether, alcohol, benzene, acetone, etc. They conduct electricity when dissolved in water or when melted. Next, we have properties of covalent compound. So the properties of covalent compound are: they are usually liquids or gases, only some of them are solids. They have usually low melting and boiling point. They are usually insoluble in water but they are soluble in organic solvents. Next, they do not conduct electricity. Next topic is occurrence of metals. So the answer is Earth's crust is the major source of metal. Metals are found in Earth's crust in two forms. First is native state, which is known as free state, and second is combined state in the form of compounds or oxide or sulfides, etc. Next, we have minerals. The natural material in which the metal or their compounds are found in Earth are called minerals. Take the screenshot. We have the definition of ores. Those minerals from which metals can be extracted conveniently and profitably are called ore. So we have a table here, students. We have the name of metals, the name of ore from which that metal is derived, and we have the formula of that ore. First we have sodium, rock salt, NaCl, aluminium bauxite, N2O3, 0.2H2O, manganese, pyrolusite, MnO2. Next, zinc. In zinc we have two, calamine and zinc blend, ZnCO3 and ZnS. Iron, hematite, Fe2O3, and in copper, cuprite and copper glans, Cu2O and Cu2S. Then last we have mercury, cinnabar, Hgs. Next topic we have extraction of metals. To obtain a metal from its ore is called extraction of metal. We have metallurgy. So the answer of metallurgy is: the various processes involved in the extraction of metal from their ores and refining are known as metallurgy. This can also come as 1 marks question, students, in the exam. Next is steps involved in the extraction of metals are: first, concentration of ores, which is known as enrichment. Next, conversion of concentrated ores into metal, and next, refining of impure metal. Take the screenshot. Next we have concentration of ore. Gangue, definition of gangue is given. The unwanted impurities like sand, rocky material, earthly particles, limestone, mica, etc. are present in an ore are called gangue. The methods used for removing gangue from ore depends on some differences in physical or chemical properties of ore and gangue. Next we have Conversion of concentrated ores into metals. To extract metal from the concentrated ore, metals are divided into three categories. First is highly reactive metals, second is moderately reactive metals, and third is less reactive metals. So we have metals and the method of extraction. K, NaCa, MgAl, they are extracted through electrolysis of molten chloride or oxide. Zn, Fe, Pb, Cu are extracted by reduction of oxide with carbon, and Cu, Hg are extracted by reduction of sulfides by heat alone. Ag, Cu, Pt are found in native state. Next, we have extraction of highly reactive metals. Highly reactive metals such as K, Na, Ca, Mg, Al are extracted by electrolytic reduction of their molten chloride or oxide. During electrolysis of molten salts, metals are always produced at cathode. Example, extraction of sodium metal. So you can see all the reaction, students. Here we have a note here. We'll read the note. Sodium, potassium, calcium and magnesium metals are extracted from the electrolysis of their molten chlorides, and aluminium metal is extracted by electrolysis of its molten oxide. We have a question. Explain the extraction of aluminium metal by electrolytic reduction of its molten oxide using suitable equations. Extraction of aluminium metals, you can see the reaction. All the reactions are given here and all the examples also. The reaction of cathode and the reaction at anode. Next, we have a next question. We cannot use aqueous solution of sodium chloride to obtain sodium metal. Why? We cannot use aqueous solution of NaCl to obtain sodium metal because if we electrolyze an aqueous solution, then sodium metal produced at negative cathode will react with the water to form sodium hydroxide. Electrolysis of aqueous solution are used to produce hydroxides and nonmetals. Next, we have extraction of moderately reactive metals. Moderately reactive metals are extracted by reduction of their oxides with carbon, aluminium, sodium or calcium. Please take the screenshot. Next, we have the definition of calcination. Calcination is the process in which a carbonate ore is heated strongly in the absence of air to convert it into metal oxide. Next, roasting. It is the process in which a sulfide ore is heated strongly in the presence of air to convert it into metal oxide. The metal oxides are converted to free materials by using reducing agents like carbon, aluminium, Na and Ca. Reduction of metal oxide with carbon. The oxide of comparatively less reactive metals like Zn, Fe, Ne, Sn, Pb and Cu are reduced by using carbon as the reducing agent. Next, we have reduction of metal oxide with aluminium. Aluminium is used as a reducing agent in those cases where the metal oxides is comparatively more reactive than zinc, etc. Take the screenshot. Therefore, displacement reaction occurs. Example, manganese and chromium oxides are extracted by using aluminium powder as reducing agent. You can the reaction is written here, students. Then note, the reduction with aluminium is highly exothermic reaction. Next, we will read the definition of thermite reaction. The reduction of a metal oxide to form metal by using Al powder as a reducing agent is called thermite reaction. The example is given. The molten iron produced in this reaction is poured between the broken iron pieces of heavy iron objects like railway tracks, crack machine parts, etc. to weld them. Next, extraction of less reactive metals. The less reactive metals are extracted by reduction of their oxides by heat alone. Extraction of mercury. First, the concentrated mercury sulfide is roasted in air when mercury 2 oxide is formed. Next, the mercury 2 oxide now is heated to about 300 degrees Celsius to form mercury metal. Take the screenshot. Next, we have extraction of copper. First, the concentrated copper sulfide ore is roasted in air when a part of copper 1 sulfide is oxidized to copper first oxide. The reaction is given. When a good amount of copper oxide is converted to copper oxide, supply of air for roasting is stopped. In absence of air, copper oxide formed above the reacts with copper sulfide to form copper metals and sulfur dioxide. Next, refining of metals. The process of purifying impure metals is called refining of metals. The most important method of refining of impure metals is electrolytic refining. Electrolytic refining of copper. So we'll read about the electrolytic refining of copper. You can see the diagram. This diagram is also given in the NCERT book of class 10th science students. See the examples at cathode and at anode. So the explanation for this is, first point, for electrolytic refining of copper, set the apparatus as shown in the figure. Before, take an electrolytic tank with the electrolytic solution acidified of copper sulfate, immerse partially 2 electrodes into the solution and connect them to battery. Switch on the, take the screenshot. Switch on the current. The anode charged electrode appears to be containing impure copper metal, which is thickened, and the cathode charged electrode appears to be containing pure copper metal, which is thinner. When current is passed, the copper metal present in copper sulfate solution forms ions and get deposited on cathode. An electrolyte solution now has less copper ions, so impure copper metals form ions by losing 2 electrons to anode and then deposit towards cathode by gaining 2 electrons. With due passage of time, the anode would be thinner and cathode would be thickened. All the impurities, highly reactive impurities, remain in solution and rest is collected below anode as anode mud. So the note is given. The electrolytic refining of metals along with the pure metal, we can also recover other valuable metals like gold and silver present as impurities. Next, we have definition of corrosion. The eating up of metals by action of air, moisture, or a chemical on that surface is called corrosion. Corrosion of iron is called rusting and is a continuous process. Rust is mainly hydrated iron to oxide. Please take the screenshot of this page. Next, condition necessary for rusting of iron. So there are 2 conditions, presence of air and presence of moisture. Next, we have a experimental question. So experimentally that rusting requires both air and moisture. So it is given. Next, we have a point topic, prevention of rusting. How can we prevent iron from rusting? So first is by painting. Next, by applying grease or oil. Third, by galvanizing. It is the process of depositing a thin layer of zinc metal on iron objects. Fourth, by tin plating or chromium plating. And fifth, by alloying it to make stainless steel. स्टूडेंट्स, इस वीडियो को हम यहीं पर एंड करते हैं. इसके आगे भी एक और पार्ट, जो लास्ट पार्ट है इसका, वो हम नेक्स्ट डे अपलोड करेंगे. स्टूडेंट्स, अगर आपको ये वीडियो अच्छा लगा हो तो प्लीज़ हमारे चैनल को सब्सक्राइब कीजिए और हमारे वीडियो को लाइक भी ज़रूर कीजिए. हमें आप कमेंट्स में बता सकते हैं आपकी क्या क्या क्वेरीज़ है और आप आने वाले टाइम में कौन से चैप्टर्स पर वीडियोस और कौन से सब्जेक्ट्स पर वीडियोस देखना चाहते हो. थैंक यू सो मच स्टूडेंट्स.